on myself at the end, because that's the least important part of this. So, I'm here to talk a little bit about cloud native patterns, and how that fits together with Camunda. I've been working with Camunda for a few years now. It's been interesting from the start, and that's why I started this also in the Netherlands, because I think the awareness should be bigger. There should be more people seeing what the options are, so they can contemplate whether they want to use it for specific projects or not. It's up to them, but at least informative way. That's the best way to go forward. So, what is cloud native? I can find a lot of different definitions of what cloud native is, but in the end, it's just a set of patterns and approaches just to be able to build a scalable solution in a different set of environments. It can be public, it can be private, it can be a hybrid setup. And how do you achieve that? Well, you can basically achieve that by having supporting technologies and tools. Most of them open source in cloud native, because that's basically one of the fundamentals from cloud native, that the community is big, and it gets bigger every day, and everyone is contributing, and it doesn't really matter who you are, where you work, everyone is welcome to contribute with cloud native. So what is the technologies and the open source frameworks and tools that are there? So we have patterns like microservices, containers, serverless, things like immutable infrastructure, things like infrastructure as code with ARM templates on Azure, or with Terraforms in general. All the things that help you or DevOps team manage their own environment in an isolated way, and be agile and be able to deliver. So the cloud native landscape has grown immensely, not just the amount of options you have, but also the amount of funding that goes into those projects. You see that there's an awareness with big corporations, with Microsoft, Google, Red Hat, all the parties involved. Basically, they see the benefits of investing in cloud native, in open source, and that's why there's such a huge traction that started a few years ago. So, going back to this, what will we discuss? Well, I kind of gathered all the components that we need. Um, so we will be using Azure. We will be using the SaaS solution for Kubernetes, AKS. We will be using Camunda, the serverless architecture with Azure Functions. Of course, as Nal and Bernd also mentioned, we need some persistence. So we will be using Postgres. We will also be using the messaging framework, RabbitMQ, storing the data of Postgres on Azure Storage and Azure Disk. And all of this will be done in Kubernetes. So I will not be using any SaaS solution besides AKS. So the patterns we have for Camunda, there are two main patterns. There are more that you can use, and I'll probably get more into that as well later on. But the biggest ones are divided within external and internal. So there are a lot of ways to run Java code internally and let the engine execute them. But our focus, at least my focus now for this presentation, will be the external task pattern, which exposes the Camunda engine through a REST API and lets other systems, APIs, or serverless functions, or whatever you want it to be, to pull the engine for work. There's support for long polling to optimize the polling experience from Camunda, so that helps as well. So this is the demo setup, how I organized it. We have our AKS cluster. We have myself that will be logging in. We have Nginx as a reverse proxy and an ingress for the people that are aware. That's actually a good one now. Could you maybe start up a poll just to see how many people are familiar with AKS, with cloud native in general, maybe?
Sure,
That would be really
absolutely.
interesting to see. So I will have an Nginx as a reverse proxy, which will handle the DNS part. Will be done on the DNS zone on Azure. It will be tied to the IP address that will be assigned to the Nginx controller pod. And we will also have a certificate manager pod running, which connects to the Let's Encrypt servers and assigns a TLS certificate for this domain name. That's the division. This vertical slicing is what I divided the internal networking of AKS, which are defined by namespaces. So I have a namespace where I have the Nginx, a namespace where I have Camunda, also a namespace where I have all the functions running, and a namespace for the Postgres database, and RabbitMQ. And outside of the AKS cluster, that's the only part that's outside of this whole cluster, is the actual resources of Azure Disk and storage to be able to persist the data. In case that poll comes back really bad in the sense of nobody knows anything about Cloud Native, these icons are all definitions within Kubernetes, pods, ingress rules, namespaces, services. I will only cover services for now. That is basically that whenever you deploy an application, every application has a load balancer in front of it, which is called the service. That way, you can easily scale 10 instances of the Camunda engine, for example, or 10 instances of the Postgres database pod, and that will make sure that every request that comes in will be scaled out evenly to all the available pods. So to go a little bit more in depth, this is a zoom in of the AKS part. We have basically here the TLS certificate enrollment, which is the cert manager part. You define a definition of it, it reads it, and it basically distributes requests from Let's Encrypt TLS certificate. The same thing goes for ingress. You have an ingress rule, which defines the DNS record, the certificate you want to use, and that way the internal scheduler of AKS knows how to request an IP address, which will be automatically created on Azure, and a load balancer to provide that capability for ingress and egress, so inbound and outbound traffic. This part will be me logging into the cockpit in a second, which will go through the ingress, which has that DNS that you saw here. I will be logging into workflow.cn labs, and I will be redirected through the ingress controller to the Camunda engine, which then internally has connection to the Postgres database. And in connection to that is all abstract definitions to define storage on Kubernetes. And that will make sure that everything I persist, or that Camunda persists, will get persisted on volume on Azure. So this is the polling setup that I set up. We have the Camunda engine. There will be two Azure functions running. This one is a timer trigger, which you can see identified by this. So every interval, it will be asking Camunda, do I have work that needs to be done? It will lock that work, distribute it to an exchange, and that exchange will route to the specific queues for the specific workers that are going to pick up that work. When the workers pick up that work, they will commit that to a new exchange. We'll put that in a queue, and there will be an aggregator function that will tell Camunda the job is done, this is the data, and you can move on with the flow. As you can see, there's not much needed here. It's very simple, just getting jobs and finishing. The more complexity for your internal business logic lies on this end. So, I want you all to pray with me because I did some alterations, which is never a good thing to do, but yeah, I love living on the edge. So, Okay, I will be sharing my complete screen now, just to give, because I'll be switching between a lot of different applications now, so that makes most sense. Okay, I hope everyone can see my screen. It's not, hopefully not too big. Okay, so as I mentioned, I have a cluster. I will skip the whole Terraform's building it. And I have my wonderful cockpit. What I will do is, since the PowerPoint presentation that I showed, I haven't exposed the RabbitMQ management portal, I will be internally routing that to the kubectl commands. So now I can access it. So as you can see, I will first start with our beautiful model. I try to make a more current model that is a little bit with the time. So this is the vaccine main program. We were going to start creating a vaccine. I looked into the parts of what goes into creating a vaccine for COVID, and you have a different set of procedures you have to go through. I also added some part of madness in this, so everyone who's here from the medical standpoint, don't correct me. It's more of a theoretical prospect model. So I have DMN tables here, the decision tables, which will, based on the name of the vaccine, give me the available country that created it and the reputation I assigned to it. If the reputation is not known or the vaccine is not known, we will end this process, because it's not fun to go forward if it's not known. That's not the case, but in this case it is true. Then creating a vaccine has different steps. So you have a small scale study first, then you have a non-clinical trial, then you have the actual clinical trials, which is referring to a different model. That is this one. A clinical trial has 3 phases, and either it succeeds and you move on to the second phase, or you stop the process and you don't stop this process, you go out of this and you don't go to phase 2. Well, if the clinical trials take too long, take more than 5 end years, we will probably end the world and we will prepare for the end of the world. So then it needs to be reviewed by someone just to make sure that it really is the case. So then we will end the world, which is the process in this situation. If the clinical trials are done within the amount of time, we will evaluate what has been done in the clinical and the non-clinical trials, the small case studies. We will start the manufacturing process, and then we will end up, based on the evaluation, to verify if it has any risks or not. If it does not have risks, we still want someone to verify that it does not have any risks based on the studies done. And if it does have risks, well, we already manufactured, so we will do a safety monitoring process and still go on. The DMN tables. I added some countries, just so you know. So we have Sputnik from Russia, we have Pfizer from USA and Germany. But let's just write down Germany, it's easier. Moderna for USA, AstraZeneca, UK, and so forth. Then we also I gave them a reputation between 0 and 100, so that reputation will be used as well. Now let's start the fun stuff. So what I did, for simplicity's sake, is I could deploy all the functions that I mentioned, and every one of these are a service, an external task service. So if you look at the definition of this, you have human tasks, which you will be able to see here in the portal in a second when that reaches there. And if it reaches here, it means it's an external task, which means in the flow that I mentioned in the PowerPoint presentation, it will be picked up by the work distributor and put in a service bus queue. And a different worker will actually do the work and send it back. I disabled all the functions so we can slowly go through the process. Otherwise, it will be done and you don't know what happened. So let's start first by actually creating one of the situations. So I have now here all the secure passwords to log into everything. And let's get started with the first process to start. What I will do is you can start the process as Bernd showed through code. I will just do it through the cockpit because it's visually more representative for the people that are not coders, since we have a mix of audience. So I will start the process. I will start the vaccine program, and I will start with Cloud Run 1 Netherlands. So this is the correlation to refer to a process instance that started. And I will start with the vaccine name because that's one of the variables I know I need in that process. And going back to this, I know that this one is from the Netherlands. I cheated a little bit, so let me start. So if I go to the cockpit and I see that there's one running process instance, I see that if I zoom in a little bit, you can see that it passed through this perfectly. And if I want to go to show what it actually did, I can see that it went through the decision table. It actually chose the Netherlands as a country. And the same thing for the reputation. The Netherlands has a reputation of 75, which I totally made up myself. So if you look at the variables that are currently now in scope, you can see that the country is available within the scope and the reputation and the vaccine that I just gave when I started the request. So currently it's waiting now for one of the functions to pick up this work. So what I'll be doing now is I will be deploying from my own environment, not here. I'll be deploying the YAML, and that first YAML will be the work distributor because that is the one that will be picking it up. So how you know that something has been picked up is if you go to the vaccine program and you click on the running instance, which is this one. You can see in the external task logs that it has been created, but there's no worker ID that has picked it up yet. So if I refresh a little bit, it means that the small scale studies has not been picked up. I will, in the meantime, if the distributor starts, also deploy the small scale studies worker and verify that they are all working. Well, I know that the work distributor is wrong because I made a typo. And with typo, I mean I forgot to replace this, which I had as a placeholder. And that's why it did not yet pick it up. So the container has started up. Let's see if it picked up the work. Not yet. Functions need to start. Let's see. Just to make sure it really picked it up. Apparently, we need to be more patient. Let me just, while it's doing that, start another instance. So I have at least all the countries running. So I will be adding the Russia run and the vaccine for Russia was the Sputnik V. Okay, let's go back to the overview, see where we are. Let's see if it picked up anything. Not yet. Oh, yeah, it did. So, okay, let's see. So as you can see, we are already done with the work because it goes really fast. It comes into the queue uh, to be picked up by this function, which is doing the small scale studies. After that, it finishes and then goes to the aggregator, which I haven't started yet. So the confirmation back, as you can see here in the overview, this has done the work. It's waiting in this queue to be confirmed to Camunda. If I don't do that in time, I can confirm as much as I want, but it will be timed out because it has a TTL. So I need to kind of hurry up. Hmm, let's see. Let's give it a little bit. Okay, so it finished. Now you see that the distributor already picked up work for the non-clinical trials. If you refresh this, you see that we've moved on to the, and if I go to all of them, you see that the three running processes are all waiting for non-clinical trials. So let's do the non-clinical trials. Let's start that also up, the non-clinical trials, and then we can also start maybe the clinical trials phase 1 and the phase 2 and the phase 3. So just to make sure they're all running. Phase. Okay. So let's see where we are now. Oh, we already passed. So let me just start one of the check one of the instances. So I'm going to check Germany. So if I want to see what happened in here, I can check the called process instances and I can see what happened there. So apparently it went through phase 1, fine, phase 2, and phase 3. Now, just for fun, I am going to add another country, which I know is going to fail at a specific process because I just have a hunch. It's going to fail at some point, I think. Yeah, but then the question is, which one was India? It was BB. Okay. So going back to the process and the India run business key, let's see where that's. I'm pretty sure that went different. Yeah, so basically it went through phase 1, phase 2, and at phase 3, phase 2, something went wrong. So we didn't get past phase 2. But regardless, we're continuing the process. And going back to the main process, we have 4 instances running. Let me start up the evaluation decision. and manufacturing, because we're going to start manufacturing the vaccine, because some vaccine providers already started doing that before approval. Then we will go to safety monitoring as well, in case it's needed. And I think that pretty much sums up all the things we needed. So let's see. Okay, so as you can see, there are two now here, and the third one, where did that one go? So let's check the history table. So Indian run completed the process. So if you look at the variables, you see that it went through this process and it had a lot of stuff. So are there any risks? Yes, there are risks. So we're going to do safety monitoring. This is the result of the clinical trials. We have phase 1, phase 2, which is 1 succeeded, 2 not, didn't. The small scale study success rate is 56. So that is all really interesting information that came out of this process. But let's go back to this one, because this one is not done yet. So as I mentioned, this one is a user task, which means you have to have some human interaction. Let's go to the cockpit and see, to the task list and see what is happening over there. So I don't see any tasks on my name. Let's go to all that have not been claimed yet. Okay, let me claim this as something I'll be picking up. Okay, so I see that phase 1, 2, and 3 have succeeded. The origin country is Germany. We have a reputation of 70. Small scale study success rate is really low. So I will mark it as it has risks, and my verdict is that there are no health concerns. So that's complete. What's this one? I will claim this one as well. This is Russia. So it has a reputation of 50. It has small scale studies of 20. Everything did go on, and we already have a lot of vaccines, also about 10 million. So it might have risks, but we're going on anyway. Let's go back to the cockpit, see what happened. No, there's nothing running anymore. We're all done. So let's check the history again. As you can see, we see that here, based on the business key, we can find the one that we are looking for. And that's something you should also know, that if you go to processes, you can, am I just missing? Oh, you can filter and search by anything. So if the business key that I mentioned, which is the correlation when you start the process, is also how you can find the process instance that is running. So this is basically what I wanted to show you, and show you that there's a lot of things possible, even hosting this whole setup in one AKS cluster. And if you want to know how, I'll probably put this on GitHub somewhere. But the functions are really straightforward. I will show you right now for the people, for the coders among us. So we have the actual functions, which is just an abstraction where I didn't do a lot. What I did basically is abstract everything away behind an interface. The only thing that happens in this one is it's a RabbitMQ trigger. It's supported by Microsoft. Besides Azure Service Bus, they also have support for RabbitMQ now. These are all variables in the environment, so I can define by configuration which queue to pick up and which connection string. And I basically do an asynchronous work process, which is all delegated in my core libraries. And in this situation, the non-clinical one, let's go there. What did I do? I get the task, I have the complete task, but the do work is the actual work. And this is all the effort that I did to do small non-clinical trial lab results. So that's pretty much how the code looks like. So we have our functions here. We have the Camunda generated Open API client. I used the Java Open API generator to generate this client. So there's nothing you have to do to call to the REST service besides consuming that Open API standard, which is something I love. It wasn't there in the beginning, but it is there now. So it's great. And the Docker file is not also nothing really complex. This is a built-in Docker template file that you get. When you start the process, you have a base and a build. The base is where you will be putting the compiled code. The build is basically to be able to compile in a container as well. That's how it is done nowadays. You don't need only a container to run it on and it push to a container registry, but also to build one. You can just use the SDK, so you don't even necessarily need the SDK, even though you're running on an IDE. So that one needs an SDK, but you could do it without it. Also, to go a little bit into the Cloud Shell part and deploying. So from the perspective of Terraforms, you can specify an AKS cluster by creating a Terraforms template and some variables that you can use to actually start this Terraform template. And I will also put this online because if you want to set up an environment to test all this out and to play around with it, this is the cheapest cluster you can get. It has the standard load balancer, not the premium one. And the great thing about it is that you can just play around with it. And if you're bored and you don't want to get big bills, you just go to the virtual machine skill set and just stop it. And then you will have no cost at all, except the load balancers and the IP addresses, which are hardly anything. That is my summary. Did I really went past my time? No. So the question part, I'm curious now.
Sure. So if you stop sharing, I can share the questions
Yes,
and you can see
I'll
them.
stop sharing right now.
So you got one or two questions. Just a reminder to everybody, there's a link there in the chat, I think, for adding more questions or voting for them.
Oh, thanks for that, by the way. I didn't see the part about the demo gods.
Yeah, I'm kind of glad you didn't now because it ties a little unfair. Okay, so first question, can you see my screen? I'll do Burns Insurance so people can see things. Can you see the questions okay?
Yeah, I can.
Yes.
I can see that.
Marvelous. So this one here, the first question was the choice of that particular reverse proxy then was by choice, or do you shy away from Azure AWS solutions on your day-to-day work as well?
Well, Nginx is part of the cloud native things if you want to use Kubernetes and Ingress. So you have Ingress controllers, which is part of the Kubernetes environment. And then you have to basically find a solution to traffic Ingress input and inbound and outbound connections. And that's the main community driven solution is Nginx. That's why I chose that. But there are also service meshes with Istio that you can use. You can also turn away from AKS and run it on really Azure native. But it's not for my day-to-day work. It's more about the showing what the potentials are for cloud native patterns and using the different tool sets they have. But as I mentioned, the landscape is big, so you can just pick your poison, basically.
Yeah, cool. Thanks a lot. I'm going to go down to this question because when Keith wrote it, I had exactly the same thing. I'm wondering how the work distributor just has any information about the tasks and if
That's a good question.
Yeah.
So I have basically written some configuration for the distributor that knows the list of relations between the queue names and the topic names. They're one-on-one related. And for each queue, they also specify the lockdown duration. So you can specify for, as Bernd mentioned in his presentation, you have some processes that take maybe 5 minutes or should take 5 minutes, and some of them should take a day or 2 days or even more. So based on that long polling timeout, you can basically distribute that for each queue independent of each other. So that's all configuration. I can share the code, but maybe that's a little bit too in depth. So, but yeah, I'll maybe share the code on GitHub if anyone needs it or there's a consensus that it's.
Awesome. Thanks for that. Next up, I'm going to go with this one, Patrick's one. I put this in for Patrick. So yeah, how you decide to implement this Java delegate has what external task if the source has been Java.
Yeah, for me it's very simple actually. For me it's about if it's small and lightweight, I would prefer to go with Java delegates. But if it needs to be scalable and if it needs to talk to different programming languages, then I would easily go to the external task pattern. And what I really like about the external task pattern is the fact that you have full flexibility. But with Java delegates, you are bound to some conventions. And I'm a .NET coder, so yeah, that's also.
In the end, you're predisposed to hate Java anyway. So
No, I love Java now, and that is because of Camunda. But yeah, I prefer .NET.
Yeah, that is a really good question. We get asked that quite a lot. I think the languages doesn't really matter. I guess you're right. It's all about where you want your business logic and how fundamental the life cycle of your business logic kind of runs. There's Patrick asked this question here, which actually I thought of as well. I do have an answer, but I'm interested in yours. And that's so obviously Camunda has its own queuing mechanism built inside it, kind of in terms of the external task list. Can you explain some of the reasons why you're using queues externally from Camunda rather than just using the list of external tasks inside Camunda?
Yeah, so one of the things I found out is that even though Camunda is really scalable, if you want to even go further than that, it gives a lot of possibilities to use external queues and persist them outside of the engine. Then you keep the engine more lightweight, and that's I think the biggest power of the external task pattern is to keep the Camunda engine as lightweight and as pure as possible. Because we also saw when we try to, but that's a different topic, to write engine plugins. You can easily also, by adding more to the engine, hit the performance. And depending on how complex it is, in the end, Camunda, for each process instance, it is a sequential process. So that means that you really do need to think about that as well in regards to your load.
Cool, thank you. And I think final question for you. Which parts of the system can be independently scaled? There was a lot of bits of the architecture and there are different reasons to scale stuff. So I'm wondering, I guess to simplify this question, you could think of scale it for performance or scale it for availability. What parts of the architecture would you scale and for what reasons?
Well, if I look at which parts would I scale, I would really keep that pattern that Bernd was talking about. You don't want to end up, if the use case is a little bit bigger, with one monolithic engine where you have everything running and you depend on that. So having for each, let's call it with the domain-driven design terminologies, for each bounded context have a proper engine that works with this external task pattern. That would make more sense for me, because then you can independently scale each of those parts. And then in regards to the queues and the lambdas, I'm going to AWS, the Azure functions, you can scale that independently as much as you want. And the benefits of using a system like AKS is that it has node autoscaling and pod autoscaling built in now. Pod autoscaling with KDA and node autoscaling just with the AKS platform. So then it means basically you can put 100 or based on your VNet setup, 1,000 virtual machines, and each of them can scale independently. So it gives you a lot of flexibility to, from the moment you pick up work, to scale anything you want.
Awesome. Thank you so much, Surush. So yeah, that was really, really great. So we've had two really, really interesting talks that have taught us stuff. My talk will be the opposite. My talk is, I'll kick it off by 5 minutes. It will be a a much more lighthearted look at Camunda in a choose your own adventure BPMN thing that I'm trying out. It will require everyone to participate in some way. Otherwise, who's choosing the adventure if not you? So we'll come back in 5 minutes, and then we will kick off with my talk. And yeah, thanks, Surush. That was really, really great. I really enjoyed that. I'm looking forward to see the code online.
Yeah, and the
See you
gods were with
guys.
us. So
Yeah,
then.
exactly. See you guys in 5 minutes.